In this segment, we are going to now solve a few questions based on similar triangles. Let's take a look at the first question. If the triangles ABC and DEF are similar, so it is known that the triangles are similar, and the area of the triangles is given. So area of triangle ABC is 9, area of the triangle DEF is 16, and the length of BC is given. Find the length of EF, right? So let us list down all that is given. It's given that triangle ABC is similar to triangle DEF, and it is also given that area of triangle ABC is 9 square centimeters, and area of triangle DEF is 16 square centimeters. We now wish to find, also it's given that BC is equal to 2.1 centimeters. We have to find, we have to find the length of EF, right? So now based on what is given, the areas are given and the triangles are similar. So we know that when two triangles are similar, the ratio of their areas is equal to the square of the scaling factor, right? So I know that triangle ABC is similar to triangle DEF, and therefore what I can say is area of triangle ABC divided by area of triangle DEF, the ratio of their areas is going to be equal to the square of the scaling factor. Now scaling factor basically means the ratio of the sides. So I can either choose AB upon DE as my sides because those are the corresponding sides, or I can even choose BC upon EF as my corresponding sides, or I can also choose AC upon DF as my corresponding sides. So now let us mark all that is equal. These two areas are equal, so I can say that area of triangle ABC is 9 and area of triangle DEF is 16. So 9 by 16 is equal to BC is 2.1, right? So now you will notice that I am not picking these two ratios because they don't matter in this question. BC is 2.1 and now I need to find the length of EF, right? So this is 2.1 by EF the whole square. And the reason that I will write for this is the ratio of area of two similar triangles is equal to the square of the ratio of their corresponding sides, right? So this is the justification behind this statement, corresponding sides. So now I know how to calculate EF. First of all, let's shift the square to the opposite side. So when you shift the square to the opposite side, it becomes square root. So root of 9 by 16 is equal to 2.1 divided by EF, right? And root of 9 by 16 is 3 by 4, which means 3 by 4 is equal to 2.1 by EF. And now you can cross multiply. So you get 3EF is equal to 2.1 into 4, which means EF is equal to 8.4 divided by 3, which is 2.8 centimeters, right? So this is how we can find the value of EF in the given question. So let me pause for a couple of seconds and then I will move on to the next question. Okay, let's continue with the next question. Looking at this question, in the given figure, PB and QA are perpendiculars to segment AB. So if you see this diagram, it's given that PB is perpendicular to AB, which means that this angle, the angle B is 90 and angle A is also 90. PO is given as 5 centimeters. So the length of PO is 5 centimeters and length of QO is 7 centimeters. And the area of triangle POB, that is this particular area, this particular triangle has an area of 150 square centimeters, right? So it's given that area of this particular triangle is 150 square centimeters. We have to find the area of the triangle QOA, right? So this is the question, which means that we have to apply the concept of similar triangles. But first of all, we need to prove that the triangles are similar, because area proposition of similar triangles can be used only after proving that the triangles are indeed similar. So I will say let's consider triangle POB and triangle QOA for similarity, right? And now let us see what all is equal. We know that angle POB is equal to angle QOA. So these two angles are equal because these are the vertically opposite angles. So the justification is vertically opposite angles. Vertically opposite angles. And we also know that angle PBO, that is the 90-degree angle, equals angle QAO, again because this is given as 90-degree, right? So this is given to us. And therefore by the AA test, these two triangles are similar. So triangle POB is similar to triangle QOA by the AA test, right? And now because these two triangles are similar, what I can do is I can use the theorem on the ratio of areas of two similar triangles. So I can say area of triangle POB divided by the area of triangle QOA will be equal to the square of their corresponding sides. So PO and QO are their corresponding sides. So it will be PO upon QO the whole square. Let us now see what all we have. We have area of triangle POB, that is 150, right? So this is 150. We know the value of PO is 7 and the value of QO is 7. Sorry, value of PO is 5 and value of QO is 7. So now I can definitely find the area of triangle QOA. So I will say 150 divided by area of triangle QOA is equal to 5 divided by 7 the whole square. So therefore 150 divided by area of triangle QOA is equal to 5 square is 25 and 7 square is 49, and therefore on cross multiplication I get, so let's find out the area of QOA now. So on cross multiplication I get 150 into 49 is equal to 25 times area of QOA, and that is why 150 into 49 divided by 25 is equal to area of triangle QOA, and 150 and 25 cancel 6 times, so 49 6 are 294 is equal to area of triangle QOA, and therefore the area of triangle QOA is given by 294 square centimeters. Yeah, so using the AA test, I first proved similarity, and then I use the area proposition of similar triangles to find the unknown area. So again, let me pause for a couple of seconds. Okay, moving on to the next question. In this question, we have to prove that AP multiplied by PC. So let us quickly shade the sides. AP multiplied by PC. AP multiplied by PC is equal to DP multiplied by PB, right? So now something comes to my mind. The question is, which triangle should I take for similarity? I think I should be picking these two triangles for similarity because the sides AP and PB, they are the sides of triangle APB, and DP and PC are the sides of the triangle PDC. So I think picking APB and DPC is the right choice. So let's see if these two triangles are similar. We have a 90-degree angle given. So those two angles are equal, and also the vertically opposite angles are equal. Therefore, by AA test, these two triangles would be similar. So let's say consider triangle APB and triangle DPC for similarity. So now let us list down what all is equal in these two triangles. I know that angle BAP is equal to angle CDP. Both are equal to 90 degree, and that is given to me. Then I also have angle APB equal to angle DPC because these are vertically opposite angles. Vertically opposite angles. And therefore, I can say that triangle APB is similar to triangle. Now A corresponds to D. So A corresponds to D. P corresponds to P and B corresponds to C. Right? So these two triangles are similar by the AA test of similarity, which means taking the ratios, I get AP upon DP. So AP upon DP is equal to PB upon PC. So is equal to PB upon PC. And this is because of the corresponding sides of similar triangles. You must have noticed that I am not taking the lengths AB and DC here because that is not relevant to the given question. So based on what the question demands, you will have to choose the right combination of the ratios that you should pick. And now cross multiplying, I get AP multiplied by PC is equal to PB multiplied by DP. And this was what I was asked to prove, and therefore hence proved, right? So again, using similarity, I first thought of the right choice of triangles. I went ahead with the similarity part and I was able to prove what I wanted. Pausing again. Okay, moving on to the next one. Let's consider the following question. In the triangles ABC, AB is 8 centimeter, then AC is 10 centimeter, and B is the right angled vertex. So I have marked it with a 90 degree. I know that AB is given as 8 centimeters. So let's write the given part. So I know that AB is 8 centimeters and BC is equal to 10. AC is equal to 10 centimeters. So AC is equal to 10 centimeters and B is the right angled vertex. And therefore what comes to my mind is I can use the Pythagoras theorem to find the length of BC. So let me quickly do that. I know that AB square plus BC square is going to be equal to AC square. This is the Pythagoras theorem. And therefore AB square is 8 square plus BC square is 10 square. So BC square is therefore 10 square minus 8 square, which means BC square is 36 and therefore the length of BC is 6 centimeters, right? So let me quickly mark the lengths. BC is 6. The whole of AB was 10 centimeters and AC was 10 centimeters and AB is given as 8 centimeters. Now P and Q are points on the sides AB and AC such that PQ is 2 centimeters. So let's mark that. PQ is 2 centimeters and PQ is perpendicular to AC. Find the area of triangle APQ. Right? So we have to find the area of triangle APQ. Let's quickly shade the triangle. So APQ is this particular triangle. We have to find its area. So now what comes to my mind is, in some way, can I prove that triangles APQ and ABC are similar? Why would that help? That would help because I can now find the area of triangle ABC, and if I can prove similarity, then I can definitely find the area of triangle APQ. So let us now draw these two triangles separately over here, and then let's see if some parts are equal. So now in these two triangles, I have drawn them separately over here. You will notice that I have kept their orientation also exactly as in the original diagram. So angle B is 90 and angle Q is also 90. Also, you will notice that angle A is the common angle, not because it is the same vertex, but because the measure of the angle A is same in both the triangles. So these two triangles are definitely similar by the AA test. So let's say consider triangle ABC and triangle APQ. Now I'm showing you how to write the proof part. So angle ABC is equal to angle AQP, that equals 90. This is already given in the question. Then I know that angle BAC is equal to angle PAQ, again because this is the common angle, right? This angle is the same in both the triangles, and therefore I can say triangle ABC is similar to triangle. A corresponds to A, B is 90, so Q is also 90, and I have AQP. This is because of the AA test, right? And now I can say that because the triangles are similar, I am going to go ahead with the idea of finding the ratio of their areas. So let's do that quickly. So now I can say that area of triangle ABC divided by area of triangle AQP is going to be the square of the corresponding side. So now PQ is the side which is known here. So I am going to pick PQ as the side for triangle AQP. Now if I pick PQ as my side, so if I am picking PQ as the side from triangle AQP, I will have to pick BC as the corresponding side. So it would be BC upon PQ the whole square, which is going to be, the length of BC was found out. It was 6 centimeters. So 6 upon 2 the whole square, which means again the justification for this would be you will have to write it. The area of the ratio of area of similar triangles is the square of the ratio of sides. So every time you should write this justification, ratio of their sides. Now area of ABC can be found out using half into base into height. So let's find area of ABC here. Area of triangle ABC will be half into, the base is 6 multiplied by the height. So this is going to be 24. Therefore the area of triangle ABC is 24 square units divided by area of triangle AQP. This is going to be 6 upon 2 is 3. 3 the whole square is 9, right? And that's why we can conclude that area of triangle AQP is going to be 24 upon 9, which is basically 8 by 3 square units. So this is how I find the area of triangle AQP. And now I am supposed to find the area of triangle PB of the quadrilateral PBCQ and the area of triangle ABC. So let me just pause for a few seconds so that you can take a look at this solution, and then I will solve the next part. Okay, so let's create some space. Now I am going to use the idea of area proposition. So what I have here is, if you consider the complete area of the triangle, I know the complete area of the triangle is 24 square centimeters. So area of triangle ABC is 24 square centimeters. And area of triangle AQP is 8 upon 3 square centimeters. Therefore, I can definitely find the area of quadrilateral PBCQ, right? So how much will that be? It is going to be 24 minus 8 by 3. So I take the whole triangle, and from that I subtract triangle APQ, and I am going to get the area of quadrilateral PBCQ. So this value is going to be 24 into 3, 72. 72 minus 8 is 64. So this area is 64 by 3 square units. And therefore, the ratio of area of quadrilateral PBCQ to the area of triangle ABC, will be given as 64 upon 3 divided by 24. And you will find that this is 64 upon 72, which is 8:9. So the ratio of area of quadrilateral PBCQ to the area of triangle ABC is 8:9. There's another way of viewing this. If you consider the complete area as A, and we know that triangle APQ has been shrunk by 3 times, that is, we saw that BC upon PQ, that is the ratio of their corresponding sides, was 3:1. So because the corresponding sides are 3:1, if this triangle, if the yellow triangle APQ's area is A, then the complete triangle ABC, the area of triangle ABC is going to be 9 times A, right? And if the complete area is 9 times A, because the ratio of the sides is 3:1, so we know that if the ratio of sides is 3:1, this is the ratio of the sides, then the ratio of the area is going to be the square of this ratio, which is 9:1. So the area of the triangle APQ is A, the area of triangle ABC is going to be 9A, and therefore this quadrilateral is going to be 8A times 9A minus A. And therefore the area of the quadrilateral is 8A and the area of the triangle ABC is 9A, which is why A cancels and the ratio is 8:9. So this was another way of looking at the same problem. So again, let me pause for a few seconds so that you understand what was done. moving on to the next question. A vertical stick is 12 meters long and it casts a shadow of 8 meters on the ground. At the same time, a tower casts a shadow of 48 meters on the ground. Find the height of the tower. So let's make a quick diagram. Suppose this is a vertical stick. It is casting a shadow of 8 meters. So this is the stick. Let us name the vertices. ST is the stick. And the shadow is TU, right? So this is the stick and this is the shadow. The length of the stick is 12 meters and the shadow is 8 meters. The stick is of course perpendicular to the ground. And the sun is somewhere right over here, right? So this is where the sun is. And then at the same time, you have a tower which is casting a shadow. So the tower is much taller. So this is a tower which is casting a shadow of 48 meters on the ground. So this is the length of the shadow. Again, the tower is vertical and let's name the vertices. The vertices are A, B and BC is the shadow. We have to determine the height of the tower. Again, the sun is somewhere over here, right? So now because it is at the same time, so at the same time is the important word. It means that the angles made with the horizontal are both equal to each other. Because the angle at which you observe the sun is going to be the same from all points, and that is why angle U should be equal to angle C, and of course angle T, which is a 90, should be equal to angle B, which is also a 90. So now if you consider these two triangles for similarity, okay, if you consider these two triangles for similarity, they are similar by the AA test. So I can say consider triangle STU and triangle ABC for similarity. So now we have angle STU is equal to angle ABC because that's equal to 90 degree, right? The objects are perpendicular to the ground. And we also have angle SUT is equal to angle ACB, again because observed at the same time. The objects are observed at the same time. And that's why the angle of elevation of the sun is equal, which means triangle STU is going to be similar to triangle ABC, right? And this is because of the AA test of similarity. So because the triangles are similar, their sides should be in the same ratio. So ST divided by AB should be equal to TU divided by BC. That should be equal to SU by AC. Again, this is because of corresponding sides of similar triangles. And now let's substitute some values here. ST is 12. So I would say replace ST by 12. And AB is what I have to find out. So replace AB by H. Then TU is 8. So let's replace TU by 8. And BC is 48. So over here SU and AC have no relevance. So we just drop it. And more importantly, make sure all the units are in coherence, right? So everything is in meters so that the value of H that we get is also going to be in meters. So now let's evaluate this. We get 12 upon H is equal to 8 upon 48, which means H is equal to 12 into 48 divided by 8, which is going to be 72 meters. Therefore, the height of the tower is 72 meters. It makes a lot of sense because if you notice 8 is being multiplied by 6 and it becomes 48. So the shadow is 6 times, the shadow of the tower is 6 times the shadow of the stick, and that's why the height of the tower is also 6 times the height of the stick. So these results definitely correspond to each other, And again, I'll just pause for a couple of seconds and we move on to the next one. Okay, moving on to the next one. So in this question, look at the diagram. It's given that angle ADE, angle ADE is equal to angle ABE. This is given to me in the diagram. So let's quickly mark that. We have to prove that the two triangles are similar. Okay. So let us first mark the equal angles. We have angle D here equal to angle B here. So now I need to prove that triangle ADE and ABC are similar. So let me quickly draw the two triangles separately so that we can visualize it better. So I have drawn these two triangles individually, and I have kept the alignment same with respect to the original diagram. So now let's see if these two triangles are similar. I notice that angle A is the common angle in both the triangles. Again, not because of the common vertex, but because the measure of the angle is same. So just because the letter A matches in both the triangles, it is not necessary that the angles would be equal. But over here, I notice that the whole of angle A is being counted in both the triangles, and that's why those angles are equal. And it's given that angle B of triangle ABC is equal to angle D of triangle ADE, and therefore I can say by A test these two triangles are similar. So I would pen it down as follows. Consider triangle AED and triangle ABC for similarity. So now what we have is angle BAC is equal to angle DAE, because that is given to me in the question, or rather it's not given actually, we are concluding it because it is the common angle. So angle A is equal in both the triangles, so this is common angle, and it is given that angle ABC is equal to angle ADE. This is actually given to me in the question, and therefore I can say that triangle ADE is similar to triangle. Now A corresponds to A, the point D corresponds to point B, so I would have ABC here again because of the AA test, right? So the first part has been taken care of. Now the different lengths are given to me, so we have to find the length of DE. So now I am going to mark these lengths in this diagram. AD is 3.8, let us mark it. AE is 3.6, BE is 2.1, okay, so BE is 2.1 and AE is 3.6. That implies the whole of AB is 3.6 plus 2.1, which is basically 5.7. We have to find the length of DE now. Now because these two triangles are similar, I can say that AD upon AB is equal to DE upon BC, right? So now let us take the different values and let's substitute them. What is the value of AD? The length of AD is again not known over here, and the length of AB is known. By the way, did we consider the length of BC? The length of BC is 4.2 centimeters. Yeah, and the length of AD is 3.8, right? So I can say 3.8. So 3.8 divided by AB. AB is, can AB be found out? Yes, AB is equal to 3.6 plus 2.1. That is going to be 5.7 is equal to DE is what we are supposed to find. So DE divided by BC is 4.2, right? So now if you perform your calculations, I can cross multiply. Therefore, DE would be equal to 3.8 into 4.2 divided by 5.7. And now 5.7 and 3.8 cancel by 1.9, which is 2 by 3. And therefore, this becomes 8.4 divided by 3, which is 2.8 centimeters. So the value of DE is 2.8 centimeters. So over here, I used the AA test. Using the common angle was one of the techniques. And once the common angle was found, I was able to prove the triangles to be similar. And then using corresponding sides of similar triangles, I was able to find the value of the unknown side. So again, let me pause for a few seconds. Moving on to the next question. Consider the following question. In the given figure, ABC is a triangle with angle EDB. So angle EDB equals angle ACB. And I think we have marked that in the diagram here. The two angles with filled with the yellow color are equal. BE is 6 centimeters. So let's quickly mark the sides. So BE is 6 centimeters. BD is 5 centimeters. And EC is 4 centimeters. And the area of triangle BED. So the area of the smaller triangle. The area of this smaller triangle is equal to 12 square centimeters, right? This area is 12 square centimeters. We have to find the following. First, we have to find the length of AB. So let us now think of how to go about it. I can consider triangle BED and ABC and they are similar. So why do I say that? I say that because angle B is the common angle. So I can say consider. Let us again draw these two triangles separately so that we can appreciate it much better. So you will notice that I have drawn the two triangles separately. So consider triangle BDE and triangle ABC for similarity. So I get angle BDE is equal to angle ACB because that's given to me in the question, right? The yellow colored angles are equal. And also angle DBE is equal to angle ABC, again because it is the common angle, right? And therefore I can say that triangle BDE is similar to triangle. Now let's note the corresponding parts. B corresponds to B, then D corresponds to C, and then we have BCA. This is because of the AA test of similarity, right? And because these two are similar, let's take their corresponding ratios. So BD divided by BC will be equal to DE divided by CA is equal to BE divided by BA. So now let us mark the corresponding sides. BD is 5, so I can replace BD by 5. And BC is 6 plus 4, which is 10, right? BC is 10. DE is something that I do not know. I need to find AB. So do I know BE? I need to find BA. So do I know B? I know B is 6 centimeters. So in this case, you will notice that I'm just ignoring D upon CA because I don't need it. And the reason for this is corresponding sides of similar triangles. So I have 5 upon 10 is equal to 6 upon BA. Solving this particular equation, I get 5BA is equal to 10 into 6 is 60, which means BA is 12 centimeters, right? So the length of BA is 12 centimeters. I can mark that. And now I have to find the area of the triangle ABC. So now, because the two triangles are similar and the triangle of BED is known, I can use the concept of ratio of areas of similar triangles. So I can say area of triangle BDE divided by area of triangle ABC is equal to the square of their corresponding sides. So what are their corresponding sides? BD upon BC, the whole square. So how much is the area of BDE? The area of BDE is 12. So 12 divided by area of triangle ABC is going to be equal to, how much is BD? BD is 5 and BC is 10. So 5 by 10 the whole square. Which means if you actually calculate this, 5 and 10 simplify by 5. So it is 1 upon 2 the whole square. And cross multiplying, you get area of triangle ABC is equal to 4 12s are 48 square centimeters. Therefore, the area of complete triangle ABC is 48 square centimeters. This is the area of the whole triangle. So over here we use the AA test. Again, the concept of common angle played a big role in establishing similarity. And then I also used the corresponding sides of similar triangles, and the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Even that principle was used in this particular question, and that is how I solved this particular question. So let me pause again. Moving on to the next one. Okay, consider this question. PB and QA are perpendicular to AB. So let us mark it. We have QA and PB are perpendicular to AB. So these two angles are 90 degrees, right? And yeah. Yeah, these two angles are 90 degrees. It's also given that PO is 6 centimeters. So this is 6 centimeters and QO is 9 centimeters. The area of triangle POB, that is this particular area, is 120 square centimeters. So let's mark it. 120 square centimeters. We have to find the area of triangle QOA. Now again, it can be noticed that these two triangles are similar again because there are vertically opposite angles and the 90-degree angles are given. So I can say consider triangle POB and triangle QOA for similarity. Let us mark the parts which are equal to each other. So angle PBO is equal to angle QAO, which is equal to 90 degrees, right? Because that's given to me in the question. And also angle POB is equal to angle QOA, because these are vertically opposite angles, right? These are vertically opposite angles. And therefore, I can say that triangle POB is similar to triangle QOA because of the AA test. And because they are similar by the AA test, I can now say that area of triangle QOA divided by area of triangle POB is equal to the square of, now QO and PO are given, so this is QO upon PO the whole square, which means that I can substitute area of POB as 120, that's known to me, and QO is 9 and PO is 6. Therefore, area of triangle QOA divided by 120 is equal to 9 upon 6 the whole square, which means area of triangle QOA is equal to 9 upon 6 the whole square multiplied by 120. So 9 upon 6 is 3 upon 2. So 3 upon 2 the whole square is 9 by 4 into 120, which is going to be 270 square centimeters. And therefore, the area of this triangle is 270 square centimeters. So I used the AA test for similarity, and once similarity was proven, I used the ratio of the areas concept to find the unknown area. So this concludes this session of similarity, and we will solve more questions in the next segment. I will pause for a few seconds before I end the session.